Hi friends, welcome back. Now for our digital input, say 1100 11101, we have our input made ready as 1 represented by high and 0 represented by low and so on. Now this high is converted into a high frequency and a low is converted into low frequency if we are using a FSK, that's a frequency shift keying, and this signal being a sudden change is there in this signal, therefore the bandwidth of this is infinite, whereas this contains only two frequencies, so F1 and F2, so that's a very band limited, so we have a band limited signal. So we have achieved infinite band signal into a finite band signal. The next step is to transmit this. So we need to transmit from the transmitter to the receiver. So we have a transmitter and we have receiver, and this transmission may be done with a point to point. So it may be through a paired wire, or it may be through coaxial cable, or it may be an optical fiber, where some physical medium is used for connecting them. The other way of working with point to point may be through radio communication, wherein we use the antenna, which transmits only in a particular direction, so we use directional antennas. So using directional antenna, we need to transmit, and this medium may contain multiple such signals, so there can be multiple transmitters, multiple receivers, all using the same free space. So in order to ensure that these don't interfere each other, then this signal is further modulated before transmission. So usually amplitude modulation is done over this, and this amplitude modulated signal is transmitted, and the other side we receive this AM signal, demodulate it, we get say FSK signal, and from FSK we decode it, and after decoding we realize that if you receive F1 it is 1, if you receive F2 it is 0, or vice versa, depending on what the protocol we have decided. So in the protocol we have decided that what is period of each, what is the period for which each bit is being transmitted. So in this case, this is one period for which a bit is transmitted, so that we need to decide, and then for 1 and for 0 what the frequencies are used, that has to be decided, and then finally with what frequency, carrier frequency, this gets amplitude modulated is also part of the protocol. So the protocol says what the this coding encoding scheme is. Is it ASK, PSK, FSK? And if it is FSK, then what are the two frequencies used for that, zeros and ones, F1, F2, and then for what period each bit is being represented. So all these together are decided before we begin our transmission. So these all are listed under rules called protocol. So the rules are already known. Transmitter knows what are the rules. So receiver also knows what are the rules. So once the receiver wants to see what is being transmitted, so it will look for this carrier frequency, and once this carrier frequency is available, because we have decided in the broader sense that between these two transmitter receiver, this pair, only one particular carrier frequency is being used. Other pairs are going to use other carrier frequencies. So these two pair are working on this particular carrier frequency. So the receiver keeps track of whether any such carrier is available. So if it finds such carrier is available, then it demodulates that signal, then it gets this FSK signal, and after decoding the FSK signal, it gets this waveform. After decoding that, we get the series of bits, zeros and ones. So once we read this, so we get a sequence of zeros and ones. So we get a 1 first, then a 1, then a 0, then a 0, then a 0, then a 1, then a 1, then a 1, then a 0, then a 1. So this is the different data we get at the receiver. So that's an overview how transmission takes place, how the communication takes place between the primary and the secondary. More details to come, so keep in tune. Thank you.